So we're going to be in Chapter 5, Lesson 7. And today we're going to talk about something called the distance formula. And today's date's 4/6/16. So the reality is Pythagorean Theorem is great. It helps us find missing parts to right triangles. But what if we don't have a right triangle, we just have two locations? And we want to figure out the distance between those two locations. And we kind of talked about this yesterday, that generally speaking, two locations are on a diagonal from each other of some sort. It could be a very steep diagonal, it could be a very flat diagonal, but it's very rare when we have things that are horizontally apart or vertically apart. So it's not always a right triangle appears. So what happens is we're often given coordinates, and coordinates, latitude, longitude, kind of look like an ordered pair, okay? Because we need those two values in order to help us. So I'm going to show you how the distance formula came about, and I'm going to show you two ways to deal with it. Way one requires you to have a graph and to draw a right triangle and to figure out a length and figure out another length and then plug it in Pythagorean Theorem. Way two is going to be a shortcut if you know just the location of those 2 points, how you can use those numbers from the ordered pairs to get to the answer much quicker. Okay? So let's start with a graph. So I'm going to pull up my graph paper. And you've got two ordered pairs, and you're asked to graph them. So graph 3, 0, and 7, -5. Then find the distance between the 2 points. Oops. And if necessary, as with all of our work this chapter, we're going to round to the nearest tenth only if we need to. So they usually say if necessary. Okay, so I'm going to go ahead and, let's see, I need to go down quite a bit on my y-axis, and I'm only to the right on my x-axis. So here's y. Let's see, 1, 2, 3, 4, 5, 6, 7. Okay, that's what I need for x. And that's pretty much what I need for my y. And then we have numbers 2, 4, 6, 8, -2, -4. So I'm going to plot my two ordered pairs, plot them in red. So we have 3, 0 is right here, and 7, -5 is right here. So the question becomes, oops, if I can draw this a little nicer. Pretend that's straight. What's the distance between those 2 points? So what they suggest that you do is figure out a right triangle that could go with this drawing. So what you're going to do is draw straight up, kind of like doing rise over run. Okay, and we can, because it's on a graph, we can count what that distance is, right? So let's see, we went up 1, 2, 3, 4, 5. And then we're going to run from one point to the next. So we have 1, 2, 3, 4. And you can see that right here in that corner, that's where the right angle would be. So this mystery value would have to be the hypotenuse because it's opposite the right triangle. Okay, so what we're going to do is figure out, using Pythagorean Theorem, what leg squared plus leg squared equals the hypotenuse squared. So we just go ahead about our business, and we get 16 plus 25 equals c squared. So that gives me c squared equals, when I add those, I get 41. But it's not c squared I'm solving for, it's c, so I'm going to have to take the square root of both sides. And I get c is the square root of c squared, and 41 is not a perfect square. So I'm going to go ahead and do my two perfect squares that it falls between, which are 49 and 36. Square root of 36 is 6. Square root of 49 is 7. And my answer is going to be somewhere between those. So it's going to be a little bit closer to, let's find out. That's a difference of 5. That's a difference of 7. So it's a little closer to the 6. So I'm going to try 6.3. So 6.3 is like 63, right? And, you know, technically we have the chart, so we could actually look on the chart, and it tells us what the square root of 41 is, too. Okay, so I know it's between 6 and 7. You need to do at least this much. And then you can look on the chart, and what does it say the square root of 41 is?
6.4.
It says 6.403. So what we're going to do is take it to be 6.4, because it asks us to go to the nearest tenth. So we would say that the 2 points are about 6.4 units apart. Okay? So now what I'm going to do is I'm going to take that same exact scenario, but I'm not going to have a diagram. Okay? And before I do that, let's just look at our ordered pairs. So this one was 3, 0, and this one was 7, -5. Now, notice that the blue height, yes?
You messed up your math for 49 minus 41, you put 7 and it's supposed to be 8.
Oh, it's 8, sorry. Can you see a connection between the numbers that gave me the vertical value of 5? Look at your ordered pairs. And can you see how we could have come up with 5 just looking at the ordered pairs? So what values in the coordinate system does this 5 pertain to? So when we're talking about this kind of line, what values are we talking about? Are we talking about x values, or are we talking about y values?
Y values.
We're talking about y values. So look at the y values of your ordered pairs. What are the y values of your ordered pairs? Are you going to answer? Okay. Right now, I'm asking a question. I'm looking for an answer. What are the y values of the ordered pairs? 0, -5. Can you see something you could do with 0 and -5 to get the number 5? What could you do with 0 and -5 mathematically to get the answer of +5? Could you add them and get +5? Could you multiply them and get +5? Could you divide them and get +5? Could you subtract them and get +5? Ah, if we subtract, we would get +5. Okay, look at your horizontal distance. What parts of the ordered pairs go with that value for? The x values or the y values? Yeah, it's on the x-axis, so that's pretty easy to see that. So what are the x values of those two ordered pairs? 7 and 3. Could we figure out how to get 4 from 7 and 3? What could we do? We could subtract them. So basically, that's what we're going to do without drawing the picture. Is we know we can figure out that vertical distance by subtracting the two y coordinates. And we can figure out that horizontal distance by subtracting the two x coordinates. Now remember what we're going to do with them. We're going to square them. So if I get a positive number and I square it, I get a positive number. If I get a negative number and I square it, I get a positive number. So it's all going to work out. So scenario 2 uses what's called the distance formula. Okay. Now, we're going to start it off and kind of compare to what Pythagorean theorem looks like. So Pythagorean theorem says you have a squared plus b squared equals c squared. What we're going to do is we're going to solve Pythagorean theorem, and we're going to get this c alone. Okay? So what I'm going to do is rearrange this and put the c on the left. Okay. But again, I want to figure out what c is, so I'm going to take the square root of both sides. So according to Pythagorean theorem, c is equal to the square root of a squared plus b squared. But the a really just represents the difference in the x coordinates. That's how I figured out that distance that was on the x-axis. And the b just represents the difference in the y-coordinates. That's how I got that vertical height. So the distance formula says this. If your two ordered pairs are x sub 1, y sub 1, and x sub 2, y sub 2, so we've dealt with those guys before, they're saying, now we're going to change c is our distance. We're going to take the square root. But what I need to do is figure out the difference in the x coordinates. So I'm going to have the x sub 2, and I'm going to subtract from it the y, or x sub 1. I'm going to square that, because that's what it says, a squared. So this represents your a, is right here. And then for the, we're going to add to that the y sub 2 minus the y sub 1. And we're going to square that, because that represents the b values, the difference in the y's. So if I don't have a drawing, and I don't want to make a drawing, and I've noticed that when you guys add a drawing instead of using formulas, you tend to misdraw your graph, and you get wrong answers. So this is going to allow you to get the answer very quickly. So let's take this formula, and we're going to use it with the original problem. Okay, does everybody have this down? Okay. Now, here's the thing that I was just hearing. A bunch of sighing, a bunch of people staring, a bunch of people not writing things down. Like, this is beyond your ability. Don't sell yourself so short. It's just a formula. And it actually gets the answer much faster than counting and squaring and adding and so on and so forth. We're just going to put it together with our coordinates. So our two ordered pairs from the original problem were 3, 0, and 7, negative 5. Oops, that's not a very good looking 5. Our distance formula said c. Now in geometry they use the letter d for distance. It says I'm going to take my two x's and I'm going to subtract them. Now here's an amazing thing. When we were doing this before, figuring out slope, if we didn't put the coordinates in the right order, we would get the wrong sign. Okay, Giselle, we're taking notes. But in this one, because the answer we get gets squared. If we happen to put them out of order, it's not going to affect our answer. So we're a little bit lucky on this one. Okay? So I'm going to change the color of the second one. Oh, no, he's good. Let's change this guy to blue. Okay. So all we would do to figure out what C is equal to is we would take the frame. That's going to look like this, and I start plugging numbers in. So I'm going to let the blue guy be the x sub 2, y sub 2. So I have 7, and then minus the x on the other guy is a 3. And then the y sub 2 is the negative 5, and then I'm going to subtract 0 from it. Okay? So this gives me C equals 4 squared. Oops, sorry, I'll make him black. Plus negative 5 squared. And we just continue on. What's 4 squared? 16. Negative 5 squared. Negative times a negative is a positive. So I get 25. And I get C equals 41. Square root of 41. And again, I can use my chart. Round it to the nearest tenth. And I get the same exact answer. Okay? So that's what we're going to be working on tonight, is solving using the distance formula. And you can draw. They give you a couple where they let you draw, and then they're going to do the distance formula. So what we're going to do is go over a couple of problems. Let's see. You are going to have to deal with some fractions and some decimals. So that's going to be fun. So let's do one of each. So the question is, find C. So let's do this one where we'll do with decimals. Our two ordered pairs are 1.52 and negative 1.5, negative 1.5. So again, it doesn't matter who's x sub 1, y sub 1. All you need to know is those are your x's and these are your y's. So 1.5, negative 1.5 are your x's, 2, and negative 1.5 are your y's. So distance formula, I always write it out when I'm first learning something. We have our two x's being subtracted and then squared. We have our two y's being subtracted and then squared. And then we're going to take the square root of the whole thing. So substituting in, I have 1.5 minus negative 1.5, so I have a double negative. And I'm going to square that answer, and then I'm going to add to that 2 minus negative 1.5. So I've got double signs. Then I'm going to square that answer. So you got to watch out with that subtraction. The subtraction is always in the problem. So this is going to give me two positives. So what's 1.5 plus 1.5? Oh, that worked out nicely. So we're going to square 3. And then here we had two positives. And what's 2 plus 1.5? So we have 3.5. And we're going to square that. Okay. Well, I know what 3 squared is. That's 9. And look at your chart. And what we're going to do is look at 3.5 is going to be the same as looking at 35. So what's 35 squared?
1,225. So 12.25.
So then 3.5 squared is 12.25. Okay? So we're going to add those two together, and what do we get? What is that?
12.3.
No. Remember, it's 9. Lines up like this. What's 9 plus 12?
21.25.
There we go, 21.25. Okay? Now, there is no 21.25 on here, so what we can do is look at what two perfect squares it falls between. 25, 16. Square root of those is 4 and 5. So we know it's somewhere between 4 and 5. And we could use our chart to look up in the square column for something that's close to 21.25. Do you see a number that's close? So do you see a number that's close to 2,125 in the chart? That would be your square number. Anybody? So we're looking for a number close to 2125 in the square column. What do you see, Nico? Okay, no. I'm looking for a number that's, when it's squared, it's that 4-digit number.
145.
Okay, 145 is well past that number.
You're looking for short six. I was looking at one.
Okay. Remember, it's got to be a number that's between 4 and 5. So we're probably looking for a number that's between 40 and 50. Do you see anything in the square column that's close to 40 or 21, 25? Okay. So what I see is 46 is, its square is, if I square this, I get 2116. That's pretty close to 2125. So I would say a good guess would be 4.6. When I square that, I get 2116. So that's what I'm going to go with. That's how I can use my chart. I'm going to say, oops, that's not equals. That's going to be approximately equal to 4.6. Okay. Now again, they don't give us any, in this particular problem, just having those two values, they don't give us any label, so we can just say units. Okay. So you're going to have to deal with decimals, and you're going to have to deal with fractions. So let's deal with a fraction problem.
Oh.
Yep, just what it is. You guys can't go through life being scared of numbers. They're just that, numbers. Let's do 2.5. 3.5 is one ordered pair. And half and 4 is the other ordered pair. So again, the main thing to remember, we have x's in the front, we have y's in the back. So when I'm using my distance formula, where I have the difference in my x's, that quantity squared, and I'm going to add to that the difference in my y's, and that quantity squared. Oops, sorry. So I get c equals. So on my x's, I have 2.5 minus a half, and then I'm going to square that. And then on my y's, I'm going to have 3.5 minus 4. And I'm going to square that. Okay, so what's 2.5 take away a half? 2. Oh, that's pretty easy. So we're going to square that one. Now, what's 3.5 take away 4? Negative
half.
negative half. And we're going to square that. So we get c equals the square root of 4 plus positive 1/4. Okay. So that gives me c is equal to the square root of 4.25. Now, the one thing I notice is that my chart never deals with fractions. So what I'm going to do is write this as a decimal. It might help me estimate things a little bit closer.
4.25.
So I know what this falls between, right? 4 and 9. So it's got to be somewhere between 2 and 3. So I want to use my chart to help me figure it out. How? Can you look down the square column and find a number close to 425? So it should be between 20 and 30. So we got 20 is 400. And what's 21? 441. So let's see which one's closer. Let's do a little subtraction. Shh. This one's 25 away. Oh, this one's only 16 away. So what's going to be the better estimate?
Higher.
Okay, the higher one. So really, we're going to look at this as being 2.0 versus 2.1. So what we would say is that the answer is about, C is about 2.1. Okay? So my chart helped me come up with those answers. So I'm using now the square column to see if I can figure out a close estimate. Okay? All right, so that's what you guys are going to work on tonight.